Okay, let me see if I can adjust my screen here so you guys can see me a little better. Okay, we're going to move on to notes number 3 today. This is going to be weather, air, and Earth's atmosphere. And we're going to start, I'm going to start by presenting this so that you can actually see it. Loading. Okay, great. Okay, so yesterday you guys watched the video of Mr. Deaton and I doing the syringe challenge. So I'm going to review some of these questions. I know I talked about this after the lab a little bit yesterday, but I'm going to review them just a little bit here before we begin. So we had the syringe with the straw on in the clip on the end to kind of block the air from coming out. When you clamp the tube closed and push the plunger down, what happens to the air? Well, we talked about how that plunger is pushing the air down, it's compressing it, pushing it into a smaller space. Is there more air or less, or the same amount of air in the syringe when the plunger is pushed down? We reached the conclusion that there is the same amount of air. There is no air escaping. We're also not putting any more air into it. There's the same amount of air. It's just being squeezed into a smaller space. What happens when you let go of the plunger after pushing it down? The pressure that we built up, so that was plugged on the end, right? When we push the plunger down, the pressure that we built up on the remaining air inside the syringe began to push back on the plunger, and it would cause the plunger to push back out a little bit. Number 4, what happens to push the plunger back out when you stop pushing the plunger? That's what I just explained to you. The air pressure being built up inside the syringe is beginning to push back, causing the plunger to go back down. And then what do you think happens to the air when it is forced into a smaller space? It just gets compressed, and the pressure, all of the atoms get pushed back together a little more, and they get kind of squeezed in, kind of like you would if you're trying to, squeeze too many clothes into a closet and you're trying to push the door, and it's pushing back on you. It's like it's getting harder and harder. Okay. It's creating the same kind of effect. So what is air? Let me get my notes real quick so I know where you guys are. I like to have the notes that you guys are looking at right in front of me, just in case there's any mistakes. Hopefully I fixed it before printing it off and giving it to you, but every once in a while, make a mistake. Otherwise, I'm perfect. No, I'm just kidding. Okay, so what is air? Air is a mixture of gases, okay? It's the common belief that most of the air we breathe in is oxygen. Okay, we talk about that a lot, how we need oxygen to survive. And that is true, but actually our air is a mix of all kinds of different gases. And surprisingly, most of the air that surrounds us is nitrogen gas, not oxygen gas. Okay, so of the air that surrounds us if you walk outside and you're kind of out in nature and you're interacting with what we call the atmosphere, or just the air around the earth, 78% of what you're interacting with is nitrogen gas, and about 21% is oxygen, with a very small amount of other gases mixed in. Okay. If I move my little screen here, there we go. Okay. Down here, you see that there's a very tiny percent of carbon dioxide gas. We'll talk about this later on in the year, but most people are at least somewhat aware that when we breathe out, the gas that we breathe out is carbon dioxide. So that 0.03%, that little tiny red sliver on the pie chart there, that is most likely from the emission or the breathing out of humans, animals, and other types of things. So the point is, air is a very complex mixture. There we go. Now, some properties of air. Air is a type of matter, which later on in the year we'll define matter as anything that has a certain mass and takes up a certain amount of space. Okay, so air is matter, meaning it has a certain mass and takes up a certain amount of space. So it's hard to imagine that air has a certain it's not weight. Mass and weight are two very different things. Mass is the amount of substance an object contains, while weight is how much gravity pulls on it. Okay. Let's talk about the balloons for a second. When I have a deflated balloon, right? If I go to blow it up, when I'm inserting air into that balloon, what happens to the balloon? Well, it begins to expand, right? That's because the air that I'm putting in takes up a certain amount of space, more space than what the deflated balloon has to offer. So that air begins to push and spread the balloon out, which causes it to blow up. Okay. So that right there is proof that when I'm inserting air into something, the fact that it gets bigger means that air is taking a certain amount of space. Okay. Also, air can be pushed into a smaller space or compressed when pressure is applied. That's what we discovered with the syringe investigation, right? When we push that plunger down, but we block it and we don't allow anything else to come in, then we're increasing the pressure in that certain amount of area. So take a look at this picture I have here, the diagram. Let me see if I can get my little pointer here. Focus mouse, maybe? Okay, here we go. Here. Okay, so down here, this is a little bit of a diagram of what the syringe would look like with the plunger pulled all the way out. Okay, so you can see the particles here. These are the atoms that make up the air or the gas. They're spread out a little more. But up here, when we push the plunger down, you see that all those particles and those atoms are squeezed together a little bit. Okay, that's compression. Okay, for example, down here, what you're looking at is a picture of an air horn. Okay, if you've ever heard an air horn, they're very, very loud. But the reason why they work is inside of this silver canister down here at the bottom, all of that air is pushed in there so tightly that when you press the button, the air comes out so fast that it makes an extremely loud whistling noise. Okay, that's the horn part of it. Okay, same thing with the basketball. When you pump up a basketball, right? If you don't have enough air in there and you try to bounce it, what happens? Well, it's a flat ball and it doesn't bounce back, right? It just drops and maybe bounces a little bit, but not quite the amount that you want it to. When you want to cause the ball to bounce a little more, you have to put more air into it, increasing the pressure, right? When you put more air into the basketball, the atoms on the inside will look more like this plunger up here than this plunger down here, okay? The more tightly packed together these atoms are, then the more pressure is built up, okay? So that's compressed air. When you compress air and you force a certain amount of air into a smaller space, you're going to increase the pressure, okay? Pressure is when compressed air pushes back, okay? The push is called pressure. So it's called a certain amount of air pressure or PSI within the object. So another example would be wheels on a tire. If you've ever been driving with a parent or a sibling or someone older and they have a flat tire, that means that you've blown a hole in the rubber and therefore all of the air pressure escapes, right? All of a sudden the drive becomes super bumpy and you can feel every little thing. Well, that's because tires have to be blown up, almost like a balloon, to a certain PSI. That means pressure per square inch, I believe. Okay. But the PSI that it has to be at is how much pressure needs to be in that tire for it to operate the way it's supposed to. Same thing with the basketball, like what I was explaining. If the PSI of the basketball is not where it needs to be, then the ball will be flat and it won't bounce the way it's supposed to. But when there's a lot of pressure inside that basketball, we've pumped all kinds of air in there. Now when I go to bounce it, all of that pressure begins to push back, causing the ball to bounce back up. Okay? That's how compressed air and pressure are related. When you compress air and push it together, you increase the air pressure. And then obviously we've discussed that air is a type of matter, which is just anything that has mass and takes up space. So in the syringe demonstration, when the air pushes back, this is what we call air pressure. Okay. As we push all of that air and compress it into a smaller space, we're creating pressure. All of that air wants to spread back out. It's pushing. Then when we release our hand, it pushes back until the plunger comes back out. Now that we've determined that air's tiny little particles, the atoms that make up air, have a certain mass, okay, they have a certain size, Because of that, they are then pulled by gravity towards the Earth's surface, okay? Which is a really good thing. That's why we're able to breathe. When you walk outside and you can breathe, that's because all of air's atoms are being pulled towards the Earth's surface by the force of gravity. The same reason that we are not floating around out in space somewhere, we're actually held on the surface of the Earth, is the same reason why we have air. Okay, are almost like an air bubble that kind of surrounds the Earth because gravity keeps pulling it down, keeping it nice and around us so that we can breathe when we go outside. Works out really well. Now, this air bubble that I was just referring to is called the atmosphere. Okay, the atmosphere is technically, this is our definition for atmosphere, it is the mixture of gases that surround the Earth. Okay, now when you look at the Earth, let me see if I can get my pen here. We'll do it in red so you can see it. Okay, so if this was the surface of the Earth, okay, let's pretend like we have a little, this is really hard to do, a little man here. Okay, so here's the surface of the Earth. The atmosphere is like a little film or a bubble that kind of surrounds the Earth. Okay, you can see in this picture here, okay, this kind of glowing white light almost right here, okay, that is the atmosphere. Here is the surface of the Earth, and then out here is space. Everything in between, so like what I circled here, that makes up the atmosphere, okay? You have to imagine almost like, okay, let's pretend we're in space, right? And you're looking at the Earth and it looks like a little, it's a marble, right? It's just a solid ball. Well, as you get closer, it would almost look like there's a little halo or this glowing kind of bubble surrounding the rest of the Earth. That is the atmosphere, okay? That is this layer of air or gases that exists all around the circle of the whole globe, the whole circle of the Earth. So that if you're out in space and you're trying to enter on and to get into Earth, right? Like a rocket ship trying to land back on Earth, you have to actually pass through the atmosphere. Same thing for if a rocket is lifting off into space. You have to go up through the atmosphere before you can reach space. Okay? So the length of the Earth's atmosphere extends from the surface to more than 600 kilometers into space. So if I were to take a little arrow and draw from the surface of the Earth all the way up, I would have to keep going straight 600 kilometers until I get into outer space. Okay, now there are different layers of the atmosphere and different characteristics within each layer that we'll get to tomorrow, but not quite today. Let me get to where I can erase. There we go. Okay, so the study of the Earth's atmosphere, scientists that dedicate pretty much most of their time to studying this layer of gases and how it's made up and how it behaves and how it changes, that's called what we call meteorology, okay? Meteorology is the study of the atmosphere. Now, the word comes from the ancient Greeks because they would call a meteor any phenomenon or like amazing thing that they would observe in the sky. Okay. Over time, meteors, which are known popularly now as shooting stars, they moved into the science of astronomy. Okay. That's where the name came from. So what's interesting, though, is these meteors, okay, these meteors happen because that is like a rock or some other object that's actually falling into that atmosphere, like what I was describing. Okay. Now that we know that air is actually a substance, right, and it takes up space, what happens when something is entering into another substance and begins moving very quickly? Well, it's the same thing that happens if you were to take your hands and rub them together like this, right? The more that they rub together, the more they interact, the hotter your hands get. You're creating what we call friction, okay? When that object is entering into the Earth's atmosphere, as it begins to zoom through the air extremely fast, it heats up. And eventually it heats up so much so that it burns up. That's what a shooting star is, okay? When you see right here in this picture, this shooting star, this is a foreign object entering into the atmosphere, okay, and burning up as it's moving because that air is creating friction, causing it to get so hot to where it actually burns up altogether. So that's where the term meteorology started. Today, we've kind of changed the term a little bit to mean the study of day-to-day weather. But it still matches because with meteorology or with weather, move forward because we're going to talk about it in just a second here. Weather is defined as the condition of the atmosphere or the air at a given time and place. So by studying the atmosphere, and which is the air that surrounds the earth, like we just discussed, okay, then you're also studying and even sometimes trying to predict or forecast the weather. Okay, so that's how the atmosphere and weather are kind of related. The atmosphere is the layer of air or gases that surround the earth, and weather is the different conditions of that air, right? Are there lots of rain? Is there lots of rain droplets in that pocket of air? Is it warm air? Is it cold air? Is it going to be windy? Is there no clouds? It's going to be super sunny. All of those are factors that we would describe when talking about the weather, and they all have to do with different conditions of the atmosphere based on what's going on in that area. Oops. Okay, that's the last one. So for the summary for today, we're probably going to skip that because I believe I had you do the, nope, I didn't. So I actually am going to have you do the summary. So again, I'm going to have you pick one or kind of form one sentence describing, okay, so the title of today's lesson, air, weather, and Earth's atmosphere. Okay. What are they? How are they related? And why is it important for us to study in relation to our Earth and Space Unit? Okay. So you're going to put that into the next slide. And then tomorrow we'll go on to notes number 4 and talk a little more specifically about the atmosphere, the different layers, and what each characteristic would be.